Okay, so here we have question number 3, part A, from May, June 2016, paper 4, variant 2. And in this question, we are asked to, first of all, part 1, draw the image of shape A after reflection in the line x equals 1. So this is a question all about transformations, and the first transformation they want us to do is this reflection in the line x equals 1. So first of all, we got to know where the line x equals 1 is. Okay, now any line that has the equation x equals something is always going to be a line which is vertical, passing through that number on the x-axis. So x equals 1 will be a vertical line passing through 1 on the x-axis, because every point on that line, the x value is 1. For example, this is the point 1, 5, 1, 4, 1, 3, 1, 2, 1, 1, 1, 0, and so on. So every point on this line, the value of x is 1. Okay, so this is the line x equals 1. So we're going to draw the line x equals 1, which should be a vertical line passing through 1 on the x-axis. I'll label this as the line x equals 1. And I want to reflect shape A in this line. Now when you reflect a shape, its image will be exactly the same distance on the other side of the mirror line. This is the mirror line, and the line joining the object, point on the object to the point on the image, will always pass through the mirror line at 90 degrees. So this point here is going to reflect 1, 2, it's going to be 2 squares to the right. Okay, so that point's going to reflect to there, and this point's going to reflect to that point over here. And similarly, the corner here is going to reflect. Got 1, 2, 3, 4, 1, 2, 3, 4. Okay, and this point 1, 2, 3, 1, 2, 3, and similarly that point will be over that corner will reflect to there. And then we should use a ruler to make sure that it's neat, and we join those points together, and we have our reflected shape. There we are. Okay. So that is the answer. Try and be a bit more accurate than that. That is the answer of part 1. So the answer to part 1 is here. That's A part 1. Okay? All right. And it says, shape A after enlargement with scale factor -2, center 0, 1. So the center is going to be 0, 1, which is this point here. That's the center of enlargement, and the scale factor is -2. Now, I personally prefer to use vectors when I'm doing enlargements. It just makes everything very accurate, rather than using a ruler and a pencil and, measuring distances. I like to use vectors because you've got exact squares here. So what I would do is I'd say, okay, let me choose a point. For example, this point here. It's the vector taking you from the center of enlargement to that point is basically -1, 0. Okay, so that point, the vector is -1 and 0, because you've got to go 1 to the left and 0 up and down. Remember, in a vector, the top number is how you move horizontally, the bottom number is how you move vertically. So from the center of enlargement, which is 0, 1, to the point here, you've got to go 1 to the left and 0 up and down. Okay? Now, to find the image of that point, you simply multiply the vector taking you from the center of enlargement to that point by the scale factor. So I'm going to multiply this by -2. That will give me +2 and 0. So I know that the image of this point is going to be 2 squares to the right and 0 up and down. So the image of this point is going to be over here. So that's one of the points I need to. That's one of the points that's going to be, the transformed for this enlargement. So I'm going to now do the same for this point over here. Okay. So the vector taking me from the center of enlargement to this point is going to be -1, +1. -1, +1, because you've got to go from the center of enlargement, you've got to go 1 to the left and 1 up. So that's going to be multiplied by -2, which gives me, again, 2, but this time, -2. -2 times -1 is 2, and -2 times 1 is -2. So from the center of enlargement, always start from the center of enlargement. I've got to go 2 spaces to the right and also 2 spaces down. So I'm going to end up over there. So this line will end up over here, and you can see that it's going to be twice as big, where the scale factor is -2, that means it's going to be twice as big. Okay, now let's take this point over here. From the center of enlargement to that point, you've got to go 3 spaces to the left and 0 up and down. So you're going to have -3 and 0. You multiply that by -2, you're going to get 6 and 0. Negative side, negative is positive again. So from the center of enlargement, you've got to go 6 spaces to the right and 0 spaces up or down. So that's going to be the image of that point. Now let's choose this point over here. Okay, the vector taking you from the center of enlargement to that point is -2, 1. So -2 and 1. I'm going to multiply that by -2. I'm going to get 4 and -2. So from the center of enlargement, I've got to go 4 spaces to the right and 2 spaces down. So now I've got a picture of what this is going to look like. It's going to be upside down. Okay, so let me just pinpoint this point now. That's going to be from the center of enlargement -2 and +3. Okay, so I'll just make another column here. So you've got -2 and +3. Okay, from the center, -2 and +3. Multiply that by -2, you're going to get 4 and -6. So from the center of enlargement, I'm going to go 4 spaces to the right. It's 1, 2, 3, 4, and 6 spaces down. It's 2, 4, and 6. So obviously the next point is going to be here. Okay, that's going to be the last point. And now I can draw my image. It's going to look like this. Now it's a negative negative scale factor, therefore, as you can see, the image is inverted. It's like upside down compared to the original. Okay, but it's twice as big in terms of its length. Okay, the lengths are all twice as big. Okay, so this is the answer to A part 2. Okay, now A part 3. It's down here. No, it's not down here. Okay, I'll do A part 3. Hold on, I'll just get it quickly. A part 3 is over here. And use this tool. Bear with me, sorry about this. Okay, this is A part 3. I'll just paste it down here. Make it a bit smaller. There we are. Should have had it prepared earlier. Okay, no problem. It says shape A after the transformation represented by the matrix 0, -1, 1, 0. So let me first deal with what this means. Now there's actually 2 ways I can deal with this. One way I can deal with this, which would actually be quite cumbersome in this particular example, would be to actually multiply the matrix, the object matrix, by the transformation matrix. So one way to do this would be to write down the transformation matrix 0, 1, -1, 0, and write down the coordinates of each of the points of the object. Okay, so I'd write down, for example, -1, 1, and I'd write down -1, 2, the x values on top, the y values underneath, and, for example, -3, 1, okay, and -3, 4, okay, and then you'd have the same for -2, 4, and so on for each of the points, and then you'd multiply these 2 matrices together with the transformation matrix first, and you'll get the image. However, I personally think that's going to be very long-winded because there's so many points. If there's just 1 point, 2 points, or something to transform, no problem. But if there's a whole shape with lots of different points, then it's better to, I think, to work out what does this transformation matrix represent. That's one of the skills that you need to know anyway. Sometimes you are asked to describe what this transformation matrix does in words. Okay, so now, the way to do this is to picture in your mind something like this. You're not looking at the points that are on the graph that you've got at all. You're just picturing a pair of axes in your mind, and you have point 1, 0, which I'm going to call I, and 0, 1, which I'm going to call J. And this matrix, which they're giving you, which is 0, 1, minus 1, 0, these represents, the first column represents the new position of I after the transformation has taken place. And this represents the new position of J, which I'm going to call J dash, after the transformation has taken place. So you plot 0, 1, 0, 1 is here, 0, 1 is here. So this is the new position of I after the transformation. This is the position before the transformation. And then J dash is minus 1, 0, which is here. Okay, that's minus 1, 0. Okay, and that is the position of J after the transformation. Then you think to yourself, what is the single transformation that will cause the letter I to move to this position here and the letter J to move to that position there at the same time? And we can see that actually if you rotate 90 degrees anti-clockwise, okay, about the origin, you'll get the image. So this is actually representing a rotation of 90 degrees anti-clockwise about the origin. Okay, so we have to just transform the image here. Okay, shape A, and we've got to rotate it 90 degrees anti-clockwise about the origin. Okay, now the way to do that is to use a piece of tracing paper. That's really what's going to help you. Okay, now I'm going to pause the video while I get what is going to be equivalent to a tracing paper on this grid ready, and then I will come back once I've sorted that out. Okay.